Hiya, Kiki here, and today I want to give you some tips on how to teach Course A of Code.org. Now, it's really important that I let you know that the majority of the courses A through F are undergoing revision, and we will be releasing those over the summer for teachers to start teaching next year. There will be more information about that coming. You might have gotten some information already if you subscribe to the email, but I'll keep you updated about the progress. Course A is not going to change that much. We are going to add a few more lessons to help give students some practice, but the other courses are changing more. So why am I showing you Course A right now? Mostly to gauge your interest. These are going to be longer videos, and I want to see if they're helpful. If you like videos like this, please give me a thumbs up. And then if you do, I will start doing more for the new courses as they get finished, maybe even before they actually come out. But we'll see how many likes this gets. If it gets over 150 likes, then I will try and get you a sneak peek to the new courses before you can even play them yourselves. I can do that. I know somebody. Okay, so Course A, let's get started. I'm going to try and go through the whole course in one video. I'm not going to show you the unplugged lessons. I will talk about them. I will play through some of these online lessons. I might not do them all, but I do want to give you an idea of what's going on and maybe answer any questions I think that you might have. If some of this brings up more questions for you, please leave comments below. I will leave a link to this course in the description box, and let's get started. Okay, Course A. When you get on to Course A, your students will not see lesson plans over on the side. You as a teacher will. There will be lesson plans for every lesson over here and a little box where you can show and hide each individual lesson. Now keep in mind, when kids are playing, they skip right past the unplugged activities. It doesn't show them to them in their progression. Unplugged activities are meant to be done as a class, so teachers will show these to kids. Now, if a kid backs out and comes back to their full menu and you haven't hidden them, they will see the unplugged activity videos in their main stream. Okay, debugging unspotted bugs. This is meant to set up the entire rest of this course. What we want to do with this lesson is get students to understand that sometimes things go wrong, and here's how to narrow in on what's making those things go wrong. Yes, there is a video here. It is cute, if I say so myself. I put this together based off of the storybook that we did in a way that a teacher wouldn't have to read it if they didn't have access to read it, or if students were doing this all individually. But the video is not as good as a circle time story. If you want to be able to stop and say, where do you think the bug is? Why do you think there's a bug there? You're right, something did go wrong. Let's look closer and see if we can find the bug. If you want to be able to do that interaction, which I highly recommend, then you will want to read the story. The same is true with Stevie and the Big Project. Now, the fun part about this is that Stevie's big project is a marble run, and then the students will end up creating the marble run after the fact. So this story is all about Stevie, who's typically an overachiever. She starts to have a hard time and then gets very, very frustrated. And her friends teach her what frustration is and how to deal with it, and what persistence is and how to be persistent in a helpful way. They then help her come back and finish her marble run. In the teacher lesson plan, you'll see that the second piece of this actually is your students creating a marble run. Now, when you read the lesson plan, you might have a gut reaction of, that is too hard for my kindergartner. And you would be right. It is supposed to be too hard for your kindergartner. It's supposed to be something that the kindergartners will fail at over and over and over again. And they'll have to either have a breakthrough, work with a partner, or ask for help in order to get to a place where they can be successful. The reason that we do this is because if we hand students things that are constantly within their grasp, they won't learn how to deal with adversity. And they need to understand how to overcome that if they're going to be coding, because coding is full of failure. And we don't want students to think that when they fail, they're dumb or that they just won't ever get it. We want them to understand, oh, that's how I find clues. When I fail, I get a clue, and then I can apply what I learned, and then I can succeed. That said, there are certainly ways that you can enhance this lesson for students that might have a difficult time. I've had teachers use tape and newspapers and have students need to roll something from a wall to a chair and then the chair to the ground. Thanks, Diane. That's a great tip, and it makes things a little more manageable. Everything's on a bigger scale and it's more lively. You can do these on smaller scales with the paper and tape, like I suggest in the lesson plan, or you can even use cardboard tubes brought from home and wooden blocks. There's so many different ways you can make this work. The point is, use the lesson plan to get ideas and then apply it to your actual classroom. But as a teacher, you will be doing your students a huge disservice if what you say is, this is too hard for my class, I'm not going to do it. Adapt it. And if you need help adapting it, email me, message me, tweet to me at Kiki versus IT, and I will help give you tips that you can then share with other teachers. Next, after we've given the students some skills on how to be persistent and find bugs, find errors, it's time to teach them what an algorithm is. Now, sequencing doesn't always come naturally to a kindergartner, as you probably already know. Sequencing is something that needs to be taught, at least the idea of what a sequence is. So, along with your normal sequencing type activities, we have this one called Plant a Seed, and it comes with its own lesson plan. What it is a worksheet that kids are going to cut out a set of squares, a series of squares that give them directions of how to plant a seed. They'll then put those cutouts in the right order, tape them on, glue them on, and then trade their algorithm with a partner. At that point, they actually will plant a seed and see if the instructions were correct. If they're not, they can debug with each other and get them to the place where they are correct so that the seed gets planted. Right now, we move from that into a drag and drop activity to give students a little bit of practice just moving pieces around. This is going to change in the new version, but only slightly. The idea will be the same. It starts with a pair programming video that I'm not going to play for you right now, but I definitely recommend you watching it because it is great to watch students work together and have one be the driver and one be the problem solver, and then switch frequently. It keeps people from feeling like they're alone in this exploration. After the video, we go on to actual puzzle piece dropping. Right now, our puzzles look like this. They are big old blocks that kids can practice moving over. And then it says, yay, continue. And it will move on. And the pieces will get a little bit different, a little more blockly-like. And students will have to practice clicking down underneath. And then as we move on, let's do something a little bit farther in the future. As we move on, they start getting more complicated. We start getting some nesting blocks. Ooh, this one, everything's out of order. So they have to actually figure out what order to put the blocks in, as well as how to click them together. Fun, right? Let's hop over here to the end. There we go. We have a 1, a 2, and a 3 now. A 1 and 2 are already clicked together. Have to bring 3 over. So now we've gone into this place where we actually have a toolbox. And then the final lesson, everything is in the toolbox and they need to drag them over one by one. Now I'm just going to use this drop down menu to get to the next set of activities. Students don't generally use those. They'll typically just go from the last puzzle into the next puzzle or into end of lesson extras, if any exist for that stage. Notice that this one would have dropped them into an unplugged activity if we didn't skip those. Happy Maps is a fun unplugged activity where students have this little furry animal called the flurb that they need to move through a grid to get the flurb to the fruit, and they can only use arrows. So they have to use arrows to plan out their program to get the flurb to the fruit. And it just uses a couple of arrows in a row, but it starts getting kids thinking about programming, about planning in advance, getting their steps out in order, and then running it and seeing what happens. Now this is all done unplugged, so they don't actually run it, but they can walk it with their fingers. And it's a fun, cute, fast, simple activity for students to do in class. If you only have one coding activity to bring to your kindergartners, this is a great one. After this is when the fun really gets started. We move into programming in Maze. The first thing we have is a video that introduces how to use Code Studio. So it talks about the Maze skin that you'll be using, and it talks about taking your blocks and putting your blocks in the right place. We do want to help students make sure that they're clicking their blocks together. We call it snapping them together so that it doesn't get confused with like click and double click. But now they get some exposure. This tells them to click the light bulb when they need a hint. You'll notice that it then double checks that they want a hint so that it doesn't give them one just because they accidentally clicked. And then it helps give them extra steps if they don't know what to do. This first one is an exploratory lesson. It's meant to be kind of drag things around, see what happens. Can you solve this? And it is a little harder actually than some of the lessons that come, because all we want to do is give them a safe place to explore. Often if students are exploring on their own, dragging blocks over, clicking run, they'll see on their own what stuff does, and then they'll get an even more detailed idea of what's happening than if they're just doing what they're being told to do. So in this case, students will drag blocks block by block, click run, encourage them to click run a lot and see what's happening. I'm going to go ahead and solve this. I don't know why. I'm sure you know what the solution is too. Very nice. That will continue them into the next puzzle, which is actually another video. And this video is on debugging to remind students about the lessons that they learned in the book before we give them a puzzle that has some debugging in it. Now, you might feel like, wait, we just barely got to programming and now you're having them debug errors? But this is very, very important. Actually, the error here is really small. It's something that kind of gives them a leg up on creating their first program. But it is important for them to know that there will be mistakes and that they don't need to just throw away all the code. They can figure out what's wrong and fix the mistakes, because there will be mistakes when they're doing their own code. And if we haven't prepared them for that, then they won't know what to do. So this one is a simple debugging problem where they just need to add one more arrow. Oddly, it's just like that first one. As we move through, the puzzles will start to get harder and harder. Now we have them doing something similar, but they need to go the other way. And in this code, they have an incorrect block. Now they need to figure out how to delete something and put something new here. As we progress, you'll get to the point where they'll need to incorporate other directions as well. So in this case, they need to move over a couple of times before they move up. These gray blocks are stone and they can't be deleted. So students have to learn how to fix it based on the code that's already there. They can't just trash everything and start over, which is helpful for them to know so that they aren't always starting over and making the same mistakes. They need to fix the mistakes that they make themselves. A bit further in here, we get to challenge puzzles. And challenge puzzles are important because they stretch the child's brain. They know in advance this is a harder puzzle, and it's a puzzle that is okay if they never pass it. They just need to try and try their hardest. And then at the end of the lesson, if they still didn't get through this puzzle, they can come back and try again once they've learned everything they need to learn. So the student gets to click, do you want to skip this puzzle or are you ready for a challenge? And then they can click that they're ready. And then it does give them this little skip puzzle button down at the bottom, only for challenges. This is important because a lot of the challenge puzzles were designed to be too hard for students. They're supposed to be too hard for the average student so that every student gets to struggle with it. The process of struggle teaches, and so they will learn, they will struggle. This one, I believe, has 2 challenge puzzles, one that is debugging and one that is not. Yep, there's the second one. And for this one, they have to go 3 different directions, up, over, and down on their own. And then after the challenge puzzles, we give them puzzles that are more simple. So these are puzzles that they would have hit somewhere kind of over in this range. And we're just going to show them those types of puzzles again. They aren't identical necessarily, but they are similar. And then that way, the student gets to apply what they've learned. There are no hints here. There are no glorified instructions. It's simply do it. And then we'll see if the students get it right. And the idea is that if they learned something here, this should be a piece of cake for them here. Plus, they just came from a challenge puzzle, which was really intense, really challenging. They might not have completed it. So we want to drop them into some puzzles that are a little more simple so that they gain their confidence back before they finish the level. So that's what programming in Maze is. We will continue on down to digital citizenship. This is an important idea in every progression. We have some sort of digital citizenship lesson because it's important that kids understand how to behave themselves on the internet. They need to know about passwords, they need to know about sharing, they need to know about commenting on things that other people share, and we teach a little bit of that every single year. We use Common Sense Education's content and then link you out to Common Sense Education if you want to learn more, and I highly suggest that you cover some of this every year so that students can be responsible digital citizens. After that, we do the unplugged activity for loops. This is called Happy Loops because it builds off of what they learned on Happy Maps. You've got the flurbs again, you've got the fruit again, you've got arrows again, but now the maps are bigger, and we want to teach students how to circle an arrow that they want to do multiple times, circle and write a number beside it so that way everything's a little more simple. They can figure out how to take a program and make it more efficient by using loops. That is something that we then have a bridging activity to link to loops in Collector. The first lesson is just a video, so I am going to pop into loops in Collector and show you what this learning progression feels like. So first, we want to get them comfortable with the skin. So we're just going to give them kind of this exploratory project, again, where they get to drop things around. Laurel's an adventure, get as much treasure as you can. Now, she needs to get at least 1, but she doesn't have to get any more than that. So all students have to figure out how to do is get to a gem and then collect the gem. And we give them kind of a tip on how to do that in the video that I skipped, but this gives them kind of an active free play type way of figuring out how to do that. Notice that the repeat block is already there, even though we don't expect them to use it yet. In fact, there's no workspace limitation. They can use as many blocks as they want on that particular level. The next one, we're going to pop them in to a lesson where loops are definitely helpful. We're going to have them do it longhand. We haven't explicitly taught loops yet, but if students are savvy and they're good at dragging and testing things, they might find loops on their own, which is a stronger way to learn than if we have to tell them and then show them and then remind them to use it. So they will go through, collect these gems in a way where a loop could be useful, but it's not required. We then show a video about loops, and then after we explicitly teach them how to use loops, we give them a puzzle where they have to use loops. So you'll notice they're only allowed to use 4 blocks to pass this. They're also only allowed to use one east block. Now notice that students can program this the long way. They can go over and get and over and get. But once they start to do that, they'll get a little exclamation point here, which tells them you've used too many of these blocks. And it will let you run it, but then it will tell you, great, now find a pattern and use a loop. So hopefully students will be able to see, oh, I have east get, east get, east get, east get, east get. Now that's a repeating pattern. They can get rid of all the repeats. They can get rid of all the repeats. Pop one of these loops in here. Now, the skill of deleting things, popping them into a loop, and re-adhering the loop to the when run button is not to be underestimated. It does take a little while. That's perfectly fine. And if your class only gets through 6 or 7 puzzles, that's perfectly okay. Every class will work at their own rate, and learning something is better than getting all the way through and yet learning nothing. So let's go down a little bit further. And here, there's some code that's already there, and students have to add to it. The neat thing is they can run the code and see what it does, and it gives them a hint for what they need to do to complete this last bit. And even if they drag this 3 out and put the correct blocks inside of it, they're going to notice it doesn't quite finish. There's still two gems left. So they will have to problem solve, what do I need to do to finish that 2 gems? And they might try and do it manually, or they might change the 3 to a 5. Whichever way, it will start to get them thinking. There's a challenge puzzle in this one as well, and then it scales back down to some more simple puzzles so that students can try this stuff on their own. And then finally in Collector, we end with a free play where they only have to collect 1, but there's so many for them to collect. So if they know how to use their repeats and they're comfortable, there is a lot that they can do here to get all those gems. If they don't and they're not, all they have to do is get 1 gem and it will be complete. Okay, I'm going to use the drop down again, and I will scroll down. There is another loops. This is loops in Artist, and it will take the artist skin and it will show students how to slowly build up to where they need to use loops to accomplish things. And it gives them a lot of ladders and stairs and things where the shapes are repeated with left, right, up, and down arrows. As you move into the older grades, you get move forwards and turns, which means you can make a lot of really exciting shapes with loops. But it doesn't work like that in the K1 user interface where it's just arrows, because you literally have to do the exact same movements in order to get a loop. So that one is fun. It is creative. It gives them an opportunity at the end to make their own thing. And after that, we go into the big event, which is a fun and very simple lesson to run. The idea is to get students acclimated to the idea that they can control a program. And more exciting, they can create a program that other people can control. And so it's playable. You can do different things with it every time. And this is a big paper remote, and you assign each button an action. And you tell the class, when I press this button, go woo! When I press that button, clap. And then you can control your classroom with these buttons. And then they start to understand that you can write a program that can be controlled using outside interventions. It's a fun lesson. It can get a little rowdy. Use your own level of comfort to determine how far it goes. But then it pops you into events and Play Lab. Now this is the one I really wanted to show you. This lesson is the one I get the most questions on from kindergarten teachers because it really is so different than the others. Adding events really does make a difference in the mental model of how a program runs, because it's no longer sequential. You now have these little pods of code that run out of order only when something happens. So we start out in kind of the same way of what we've learned before. This is a play lab level, move blocks to the workspace and see what happens. Kids can just start testing things. So they can change the background and they can make it a desert, and they can, let's make the dog, I don't know, maybe I'm feeling ornery today. Let's make the dog angry. And then you click run. Wow, that dog is not happy to be in the desert. And they can see how their program changes the environment. Now, the next thing we get to is a place where it actually matters what the dog says. Now, it says Jorge the dog wants to say, "Hi there, can you help him?" Little backstory information, little backstage information. It doesn't have to say hi there. Actually, whatever the dog says is okay. We just want the student to drag the block over to when run, and then click run. Good afternoon. And we've completed it and we can continue forward. Here come the events. So the instructions are long and they're kind of hard to read because students need to scroll because they're so long. There is a play button so that you can play the instructions for non-readers, but really what's important are the blocks that are involved here. So Jorge the dog needs to move, and that needs to be connected to the when run block, when left button block. And then we have to get Jorge to the flag to finish the level, and in order to do that, we need to click the run button. There's the flag Jorge needs to get to. And that means that the student is going to have some interaction with their program after they click run. Coding is not the only bit of this here. Now notice that this when left arrow clicked event is corresponding to that or the left arrow key on their machine. So we need to find the Jorge move left block and click it there. You'll notice that our code from before is simulated here. It does say hi there, because that's what they were supposed to put, and if they put something else they will lose that. But what we're trying to do is give them the feeling that they're building their code up, and later they will be. But for this one, we've kind of got this progression happening. We'll click run, and then when we click on our arrow, Jorge will move, get Jorge to the flag, and the level is complete. From there, it builds even further. Wow, there's a lot here. And the reason there's a lot here is because I have already played with this level and I probably shouldn't have. So what I'm going to do, you can see all my hints are open because I was testing out hints. But if we go to version history and we click start over, I can get it back to where I'm supposed to be for this puzzle. The next thing I need to do is get Jorge to move right. And so I'm going to bring out a when right event block, and then I'm going to bring out the move Jorge right block. And you'll notice if you go down in the hints, it does tell you that those are the things that you need, and eventually it lets you know what you need to add. But those are hidden behind buttons, and students won't learn that unless they need the help. And then we click run and we get Jorge over to that flag and we can move on. So hopefully this is giving you an idea of how to use those events as non-sequential players in this code. Now the code that is underneath these buttons will run sequentially in and of themselves. So if I add 3 more blocks here, they will run in order, but it doesn't mean it will run this and then run this. It will only run this when I click this right arrow button, and it will only run that when I click the left arrow button. Now Jorge is in space and needs to get these other 2 flags as well. You'll see we still have the left and right at play here, but we now have up and down. So now Jorge needs to be able to go up when up is clicked and down when down is clicked. And you will see that students will need to learn how to modify that parameter on their own in order to get the correct button. They'll need to do the same thing with the move Jorge button as well. They'll need to come over, they'll need to figure out that Jorge needs to move down. And when we click run, you don't see me pressing the buttons on the screen because I'm using my keyboard, and I'm getting Jorge to the flags. And we are good. Okay, so we give the students this entire program that they've written so far and challenge them to make it more interesting by changing the background and playing a random sound when Jorge's clicked. So I am going to move this so I have some room, and I just need to make sure this when run isn't deletable. Okay, it's not. Good. Now we want to change the background. Let's set the background to random and play a random sound when Jorge is clicked. Okay, so click run. Now click Jorge. Woo. All right. Oops. And finally, we have a free play. So here the students can take everything they learned and actually turn this into a game that's fun for them. We have when clicked, we have another sprite on the screen, and when they collide, there can be an event that happens. You can make it so that when they collide, it changes the background. You can set the mood. You can add a score so that when they collide, you can add a point. You can have the dinosaur vanish when they collide. There's all sorts of things that students can do to kind of turn this into their own game. It is fun, it is special, it is creative, and it is just enough to give a kindergarten this feeling that they created something and that it's a special opportunity. So I'm going to bring them over here. Woo! Vanished him and added a point. Well, unfortunately, in this game, 1 point is all I can get. So I am going to call that good. You'll notice that we are all out of levels. There's nothing else down there. That is the entirety of Course A. Thank you for joining me. I hope this was helpful to you. I hope that you feel like you can bring this to your kindergartners. Again, click like if this type of video is helpful. If you'd like to see me do this for the new courses as soon as they come out, subscribe to my channel. It helps me understand whether this content is something that is useful to you out there. And if you want to see videos as soon as they're posted, don't forget to click the little alarm bell. And that's it. Until next time, happy coding.